Today, we'll explore how mobile device management, or MDM, works and why it's essential in both enterprise IT and telecom environments. Think of MDM as the control center for smartphones, tablets, and laptops, ensuring they stay secure, compliant, and correctly configured no matter where they are. At its core, MDM allows organizations to remotely manage devices that connect to corporate systems. This means IT admins can enforce password rules, install or remove apps, push Wi-Fi or VPN settings, and even lock or wipe a device if it's lost. For solution architects, MDM forms the device policy enforcement layer, bridging enterprise identity, applications, and network access. The MDM ecosystem usually has three major components. First, the MDM server, a central platform like Intune, Workspace ONE, or Mobile Iron. It stores all policy configurations and talks to identity systems like Active Directory or Azure AD, certificate authorities, and app stores. Second, the device agent, a small app or system service on the device. It receives MDM commands and applies them locally using platform APIs like Apple MDM API or Android Enterprise API. And third, the push notification service. This keeps the communication efficient. Instead of maintaining an open session, the MDM server uses APNs for iOS, FCM for Android, or WNS for Windows to notify the device that new instructions are ready. Now let's walk through the lifecycle of an MDM managed device. It begins with enrollment. A user registers their phone through a company portal, QR code, or an automated process like Apple DApp or Android Zero Touch. During enrollment, the device receives a management certificate. That's how it authenticates itself to the MDM server. Next comes policy delivery. The server sends configuration payloads, like Wi-Fi SSIDs, VPN profiles, or app restrictions, in a secure XML or JSON format. Finally, command execution. The device downloads these settings, applies them locally, and sends a status report back to the server, success or failure. Security is, of course, the cornerstone of MDM. Communication between the server and devices happens over HTTPS, with mutual TLS authentication. The system enforces data encryption, remote wipe, and containerization, separating corporate data from personal apps. That's especially important in BYOD environments, where you don't want to invade user privacy while still maintaining compliance. From a solution architecture view, MDM integrates tightly with enterprise systems. It connects to identity providers for conditional access, to VPN or proxy gateways for secure tunnels, and to mail servers for auto-configuring Exchange or Google Workspace accounts. It can also send logs to CM systems like Splunk for security correlation, or synchronize device inventories with tools like Microsoft Endpoint Manager. In short, MDM acts as the control plane of the enterprise device ecosystem. Now, let's consider MDM from a telecom operator's point of view. In telco environments, MDM often connects with device management platforms, handling things like eSIM provisioning, policy delivery, or photo updates. It can also indirectly integrate with core network elements such as PCRF, AAA, or DRA, especially when enforcing device-specific network policies or data access restrictions. In IoT scenarios, protocols like OMADM or LWM2M extend MDM concepts to millions of connected devices, routers, sensors, and embedded modules. Here, MDM ensures that devices stay patched, correctly configured, and compliant with operator policies. To summarize, MDM gives enterprises and operators a unified, secure way to manage mobile endpoints. It provides visibility, policy control, and remote action, all without manual intervention. So in the bigger picture, think of MDM as what the PCRF is to a telecom network. A policy brain that ensures every connected endpoint behaves exactly as intended. And that's the essence of mobile device management, the silent architecture that keeps the mobile world secure, connected, and compliant.